Welcome to the Ingenuity project. In this video, I'll be demonstrating how quick and easy it is to produce high-quality and feature-rich applications with Enginuity. At the heart of Enginuity is a novel method of connecting and organizing modules. Modules are intuitive and easy to use because they correspond to real-world devices and processes. Modules are connected in a parent-child hierarchy using a single channel rather than a multitude of individual signals. With this kind of paradigm, one must think in terms of what a given module has. In the demonstration you're about to see, the tank module has an intake device and it has a discharge device. Each of these devices can be either a pump or a valve. I'm going to walk you through the simple tank example and show you how everything works. We have the tank program open, and the first thing I'd like to call your attention to is the variable definition area, where we have declared three module instances: tank, pump, and valve. We come down to the code area. We notice that each of those instances are represented by a block, and where each block is labeled with the instance name and the module name or the module type. There's a single connection between modules, and this connection establishes a relationship between the two modules, and in this case it's a parent-child relationship, and we know that because we have connected the parent module's ID number to the child module's parent input pin. And that's what makes this be a parent-child relationship. Now, it's possible to have other kinds of relationships. The two that we have defined so far are peer-to-peer and client-server. So a module that has a parent-child relationship with one module, it could have a peer-to-peer relationship with some other module. That's beyond our discussion today. We're only dealing with parent-child relationships. Now, this parent-child relationship is the basis for communication between these two modules. So when I establish this relationship, that makes it possible to communicate in either direction. And so what we end up with is, instead of a signal that goes from one module to the other, we have a channel, a bidirectional channel. That's how we should think of this connection. It's a channel through which these two modules can communicate with each other. Now, the details of that communication are worked out by the module designer, whose responsibility is to see that these modules are able to work together, and so to achieve whatever the desired behavior is. So in doing so, and leaving that to the module designer, it's not necessary to expose those nitty-gritty details to the application level here. Doing so would just add complexity and confusion to our program. And really what we're trying to achieve with Enginuity is we're trying to maintain a simple programming paradigm that makes our programs easy to understand and easy to work with. So there's no point to add unnecessary complexity. So now that we've established a communication channel from parent to child, and also from parent to child, so the tank module now can communicate with the pump module. They also can communicate with the valve module. It's still not sufficient. We still don't have sufficient information for these modules to work together. Now, why is that? It's because the pump must have a purpose. The tank module must know the purpose of the pump module. And and the way we know that is by specifying a role. So what role will pump fulfill within the scheme of our system here? And to know that, the parent module defines what roles it expects to be fulfilled, or what roles that he knows how to interact with. And so I've opened up the reactor module's source code here, and we're looking at its documentation. And over in the documentation, he says, okay, I have an intake role that's required, and I have a discharge role that's required. And either one of those roles can be fulfilled by a valve or a pump. And so if I come back over here, we can see that yes, we assigned the intake role to pump, and we specified discharge role for the valve. So now at this point we have everything connected up. We've specified the roles. And so we should be ready to compile our program and download it. And one last thing I'd like to point out, and now there are these pins down here, they're designated with lowercase I and lowercase o's. The lowercase I and lowercase o tells us that these pins are intended to be connected to hardware I/O points. And that's beyond our discussion today, so we're not going to talk about that anymore. We're just going to leave these pins unconnected, and we're going to compile and download our program to see what happens. I have already compiled and downloaded our program. Now we only have to log into the PLC. We can do that by clicking on the little icon up here. And here we are, we're connected to the PLC that's running on my computer. And the first thing we want to notice is that all the ID numbers have been assigned. And the little pink boxes show us the actual values that are in memory. And the other thing we want to take a look at is here on the role input. We've assigned intake as the value, but it actually has a value of pump. Well, that's the default value, and the default value is going to be the instance name of the module. And we use that default so that if the instance name was the same as the role that we wanted to take, then we wouldn't have to make this specify a role out here. And we did that because we realized that very often the instance name and the role would be one and the same thing. And we couldn't see the point of making the programmer have to type in the same thing twice. So we just made the instance name be the default value for role. And if you leave role unconnected, it will end up being the instance name. So let's go online. We could do that by clicking this little icon up here. And now we're running. And we can see here that our specified role got written to the input parameter. It's now in memory. Same with discharge. We look at the tank. We see that now he's still got the default value. That's because the pin is not connected to anything. The other thing that we noticed that happened, and it's sort of not very exciting at this point, but a value got written to the status output. Let's go take a look at that and see what that's all about. Now we can, the little arrow there says that there's more inside this than we can show in the pink box. So if I hover over it in the right place, another little box will pop up that shows us the entire contents of that output pin. And what we can see is that this is more or less an error or a status message. And we've done this. We've implemented a status message or an error message in place of an error code. Didn't see the point of outputting an error code that had a number that you would take and go look up in the documentation somewhere to find out what the number meant. Doing it this way, we figured, like, why don't we just tell you what you would have found out anyway? No point making you go look it up. We could just tell you. And we have one other advantage, since we're generating the text right here at the module where the error or the condition occurred. We can also grab data out of memory that represents that was present when this message was generated. So, like in this case, where he says connect parent tank to child valve, the things in parentheses, tank and valve, are actually data that was captured when this message was generated. So we're actually able to tell which parent and which child got connected here. If we were using the error code system, we'd go, after we looked up the error code, the only message we would get is successfully connect parent to child. And you wouldn't know which one got connected to which one. So let's take a little closer look at the format of this message. The first character is a severity level, and the severity level tells us what kind of message this is. The S indicates that this is an Enginuity system informational message, and we get these when good things happen. And this message indicates that a connection was successful. If this connection was not successful, we would have got an exception instead, and that would have had a severity level of X. There are 4 additional severity levels that can occur from conditions that occur from the application. And those are I for information, W for warning, E for error, and F for fault. They're more or less self-explanatory, but on some later video or in documentation, we'll describe those conditions in more detail. Now, the next part of the error message are the topic and subtopic. And in this example, connect.child are the connect is the topic and child is the subtopic. And these two together help identify this condition. It's unique. This combination is unique within the module type where the condition was originated. And then the next part is the descriptive text, and as we were talking about before, that descriptive text can have data embedded into it. So I'd like to talk further about this diagnostic message. Underlying this message is our diagnostic system. And what happens, there's a system call that either system code or application code can call, and when that's called, it generates a diagnostic event. And that diagnostic event is populated with the information that's in this message, plus a timestamp, plus the instance name of the module where the event originated, and the module class or module type where the event originated from. That data is stored in a structured data type, and it's written to a circular list. And that circular list is available to other modules and available to HMI systems for display. And it could be made available to other modules where it could be streamed out to a file or to a database so as to keep a permanent record. And so hopefully you can see by what what you've seen so far, you can kind of see where we're going with this. We're trying to develop a system that produces programs that are intuitive and easy to understand, that are easy to build, and easy to work with as far as maintenance and diagnostics. In a second, I'm going to show you an extra special added bonus that we get from having modules that are able to connect to each other and that have a common means of communication, and by having a universal diagnostic system. What I'd like to show you now is the beginnings of an extensive and complete HMI-based diagnostic system. What we're seeing in this pane here is the native HMI system, and we're implementing our diagnostic system here at the moment. We intend to also implement the equivalent on an external HMI system. Specifically, we're going to do it on Ignition first, and then we can do it on other external HMI systems by request. So let's look what we got here. We have a navigation pane, and the idea is we want to be able to navigate to different modules. We select a module, and we go over to the view pane and view different aspects of the module, and then in some of the views we're able to interact with the module directly or indirectly. We have two view panes, the top and bottom, and they're virtually the same panes. Any information you can see on the top, you should be able to select and see on the bottom as well. Now, we're sitting here right now. We're navigated to our tank module, and you see right here we have our parent is the root module, and we have a pump and valve module that are a relation to our child. And if I were to click on one of these entries, we would navigate to that module. And so now valve is the current module, and we'd be looking at data that was relative to the valve. I could click here on the parent tank and go back. Now, what I'd like to comment on here on the navigation, I would have preferred to have used a tree widget, similar to the kind you find in most file browsers. But unfortunately, the native HMI system does not have a tree widget, at least not at this point. So, now, Ignition, that we're going to also deploy the system on, Ignition does have a tree widget, and we intend to take full advantage of its availability when the time comes. So, we look at the first tab here, Info, and what that shows us is just some general information about the module that we've selected. And like a lot of this module is also available if you're in here looking at the codes. You'd be able to see much of the same information. Now the second tab is Module. And so we'll go down here. We already have module selected down here. You might as well use the bottom view pane. And what we see in the Module tab are diagnostic events that originated from the current module. So Tank had 4 diagnostic events. They all had a severity level of S, which means this was a system informational message. And he's basically bragging that he successfully made connection. Now, we click on the System tab. We get a list of diagnostic events. And basically, this is a list of all the diagnostic events that are contained in the circular list. So now, Up on ignition, the circular list can be streamed out to a database or to a file. And so you may have a view up there to also look at the entire history and just not the circular list. We have a control panel. Now let me explain how this thing works. Not fully implemented yet, but the screen is implemented. But what we intend here is that this control panel be configurable based on the module type that is currently selected. So if were selected tank, that would be a WTR reactor type module, so we would get one configuration of control panel. If we clicked on and pump was our current module, then WTR underscore pump S1 would call up a different configuration for this panel. And the way that works, each one of these components here is displayed in a frame. And then there's a title underneath, and then there's also a visibility property. So each module type then would have a configuration data that would tell each of these components which screen to display inside the frame. We have 9 or 10 defined so far, and they range from anywhere from a push button to toggle buttons, LEDs, numerical display, numerical entry, horizontal bar graph, that sort of thing. And so when I select, if we're on pump, we get one configuration here. Many of these wouldn't be visible, possibly. Others would. Some would be toggles, some would be push buttons, some would be LEDs. And we'd have all different title text here. And so we believe we can make this to work. We just have to, just a little bit of work calling up the configuration data and specifying the configuration data is what's left to do. This idea brings up another feature that we would like to do, but don't believe it's possible in the native HMI. And it's similar to what we're doing configuring this panel, but instead of having a configurable panel, what we'd like to do is for every single module type, we'd like to have a list of views, customized views that we can call up for each specific module type. And the reason that we have a limitation on the native HMI is because the way frames work on the native HMI. On the native HMI, the frames, the screens that are used in the frame have to be selected beforehand. They're assigned an ID number, and then the way you select the frame to be displayed is by the ID number. On ignition and other external HMIs, the way you specify what screen is to be displayed inside the frame is by name. And the reason that's important is that our intention is to have, eventually to have domain-specific libraries with them. Right? And the reason we want to do that is we want the modules in the library to correspond to entities that people who work in that domain are used to working with. Again, if we maintain that one-to-one correspondence with reality, then our resulting programs are intuitive and easy to understand and easy to work with. And that's really what we're trying to achieve. So what would be really nice if I had a pump module, I might want to have a view that has a graphic depicting a graphical representation of a pump. And maybe I might want to have show the pump rotor, and if the pump is on, I can show the pump rotor rotating. Or I could have some other animation showing fluid circulating through and flowing through the pump. They may have, 5 or 6 other custom screens that are specific to that pump or the pump type. And so all we would have to do under ignition is to configure that. We'd have a folder with the customized screen or screen templates. It would be copied up to the HMI server somewhere where ignition could find it. And then when we select a module, the module would have to tell the HMI, giving a list of views that he's able to access and communicate with, and load up the additional tab buttons with those selections. And then when you click on the button, it would simply copy the file name and location into the frame, and then the frame would display that screen. So we're going to continue looking on the native HMI to see, continue looking for a way to implement that sort of thing. But right now it doesn't seem like it's possible. And so I think we're going to end up with, on the native HMI, it's going to be a subset of what we're really going to do up on the external HMI. And then that's why I say when we're talking about an extensive diagnostic system, I really mean extensive. Every single module type in every library will could conceivably have its own custom views, like 4 or 5 or 6 of them. And we can afford to do that because we only have to do it once per module design, and that effort gets amortized over numerous and many usages. And so that's why I say complete and extensive HMI. Anyway, I hope you have some idea of the vision that we have for Enginuity. We want to end up with programs that are easy to build, they're easy to understand, and easy to work with for the programmer and for the end users alike. And we want to have an extensive diagnostic system to go along with that, again, for the end user, so that they can diagnose their system. And we want that system to be able to be deployed with 0 effort. In the demo, we saw how modules connect together in a parent-child hierarchy and how to view their details using the browser. Hopefully this is the beginning of a quick and easy way of producing high-quality software. If there was something you didn't see, it's because we haven't done it yet. The project is in early development and we are working on the infrastructure that makes all the cool stuff possible. A demo project will soon be released, so you will have a chance to try some of this stuff for yourself. There is so much more to Ingenuity than can fit into this video. If you want to find out, you'll have to wait for future videos or follow our progress on the website.